Hello students, today we will discuss on the introduction to digital signal processing. Myself, Sinha, assistant professor in electronics and communication engineering department, Haldia Institute of Technology. So today we will. So before I proceed to this topic, this lecture is meant for the students of EC, electrical engineering and computer science engineering. In addition, it should be useful for any enthusiasts who would like to understand this topic. This lecture explains the basic concept of digital signal processing in a simple and easy to understand manner. So digital signal processing actually deals with the signal phenomena. So before proceeding with this lecture, the students are expected to have a basic understanding of the engineering mathematics as well as the signal and system subjects. Now if you just try to understand the history of this digital signal processing, so signal processing emerged soon after World War I, First World War, in the form of electrical filtering. With the invention of the digital computer and the rapid advances in VLSI technology, during 1960s, a new way of processing signals emerged, and that is the digital signal processing. Now, in today's era, DSP is everywhere. So, if we considering that in our daily life that we are using mobile phone, we can find there DSP used, and if we consider that smart TVs, they are also DSP used. If we consider that smart watches, they are also DSP used. So any electronic gadget in today's era, whatever we are actually using, that is actually the application of DSP. Now if you just try to understand that signal from that digital signal processing name, if you just try to understand what is the signal, then typically one can assume that a signal is an electrical signal, for example a radio, radar or TV signal, and a radio signal represents the strength of an electromagnetic wave that depends on one independent variable, namely time. The world of science and engineering is filled with signals, images from remote space probes, voltages generated by the heart and brain, radar and sonar echoes, seismic vibrations, speech signals, signals from GPS satellites, signals from human genes, and countless others. So in a gist, a signal is defined as a physical quantity that is varies with time, space, or any other independent variable or variables. In our generalized definition of a signal, there may be more than one independent variable, and the independent variables may be any quantity other than time. For example, a digitized image is a two-dimensional signal, 2D signal, and a video signal is a three-dimensional signal or 3D signal. Now, some signals arise naturally and others are man-made. So, natural signals are found in acoustics. So, example of acoustic signals are speech signals, sounds made by dolphins, and next astronomy. So, cosmic signals originating in galaxies, astronomical images, biological signals, so signals produced by the brain and heart, seismology, so example of that the signals produced by earthquakes and volcanoes, physical sciences, so signals produced by lightning, room temperature, atmospheric pressure, and man-made signals, they are found in audio systems, so example is the music signals, communications, the examples are the radio, telephone, TV signals, telemetry, the signals originating from weather stations and satellites, control systems, the feedback control signals, in medical, electrocardiographs, X-rays, magnetic resonance imaging. And in space technology, the velocity of a spacecraft. Now, if we consider digital signal, very specifically, that three general classes of signals can be identified. If we just consider that, if we just write that signal and we just classify it into three: continuous time, signals or analog signals, discrete time signals, and third one is the digital signals. So first one, continuous time signal. When a signal is defined continuously for any value of an independent variable, it is called as an analog or continuous time signal. Most of the signals encountered in science and engineering are analog in nature. When the dependent variable of an analog signal is time, it is called continuous time signal and is denoted as xt. So if we just consider continuous time signal, so it is continuously varying with time. So if the x-axis is t, time, then y-axis will give you xt, and the signal is continuous with respect to time. Now second one, that is the discrete time signal. When a signal is defined for discrete intervals of an independent variable, it is called a discrete signal. When the dependent variable of a discrete signal is time, it is called discrete time signal and it is denoted by xn. Most of the discrete signals are either sample version of analog signals for processing by digital systems or output of digital systems. So if we just try to draw a graph of discrete time signals, so if we considering that that continuous time signal xt is discretized after sampling, so it is no longer exist in continuous in nature with respect to time instances. So if we consider now time index is small n, then the signal will be represented as x of n. And here you can find that in several time instance, that is at 0, at 1, at 2, at 3, at 4, at 5, at 6, this signal is present. But in between 0 and 1 or 1 and 2 time index, there are no existence of the signal. Now third one, that is the digital signal. The quantized and coded version of the discrete time systems are called digital signals. In digital signals, the value of the signal for every discrete time n represented in binary codes. That is important. The signal is no longer in, you can not present it in graphically, so it is now presented in binary codes. So binary codes are in terms of 0, 1. Okay, the process of conversion of a discrete time signal to digital signal involves quantization and coding. So you can say that a digital signal is represented as, suppose, some combination of 0 and 1s. So 0, 1, 1, 0, 1, 1, 1, 0, 1, 1. Looks like this nation. Okay. Now we have already understand what is the signal, what is the digital signal. Now comes the signal processing. What do we mean by signal processing? So signal processing, just like that processing of signal. Okay, how can you modify the signal? How can you analyze the signal? So basically, humans are the most advanced signal processors. For example, speech and pattern recognition, speech synthesis, etc. Signal processing involves analyzing, modifying, and synthesizing of the signals. So that is important. Signal processing involves analyzing, modifying, and synthesizing signals. So we encounter many types of signals in various applications, and most signals, most real world signals are analog or continuous time. Now analog circuit process these signals using resistors, capacitors, inductors, amplifiers, etc. So for an example, that audio processing in FM radios, video processing in CRT TV sets, etc. Analog signal processing deals with transformation of analog signals. Processing is done using electrical networks consisting of active and passive elements. But the digital signal processing deals with the processing of discrete signal. Processing is done using general purpose computers, ASICs, FPGAs, DSP chips, etc. So basically, you can consider that signal processing can be done in terms of two categories if we classify signal processing. So first one is the analog signal processing. Analog signal processing. And second one is the digital signal processing. So analog signal processing is deals with analog circuits and analog signals, that means continuous time signals, and digital signal processing actually involves digital circuits and digital signals or discrete time signals. Okay. Now, what is the limitations of analog signal processing, or why we are moved forward for the digital signal processing from analog signal processing? So there are certain limitations of analog signal processing. So first limitations, that is the accuracy limitations. So it is not the accurate. So accuracy limitations due to component tolerances and desired non-linearities. So analog circuits involves some components, active or passive components, and for their tolerances and undesired non-linearities, there are limitations in accuracy. Next, limited repeatability due to tolerances and changes in environmental conditions. So analog circuits are actually environment have the great effect on that circuitries. So due to changes in the environmental conditions, temperature, vibration, etc., maybe there will be changes, okay, and changes in the tolerances also. Next point, sensitivity to electrical noise. So due to electrical noise, maybe there will be certain issues in sensitivities. Next point, limited dynamic range for voltage and currents. So range is also limited. Inflexibility to changes. So it is not flexible. So if you want to change, if you want to modify the circuitry for the signal processing for different application, you have to change hues. Okay, you have to modify the maximum components. So that is inflexibility in design. Okay. Next, difficulty to implementing certain operations. So non-linear operations, time varying operations, etc. And next, difficulty of storing information. That is a huge difficulty. If you want to store that analog signals or real world signals, so you need that huge storage. Okay, that is not possible. Okay, so that is the difficulty of storing information. Okay, but for the case of digital signal processing, we will see later that we can store it very easily, and we can also process it. Okay, if you want to process it further, and after that that particular process, you can also do that. Next, digital signal processing. So we for that limitations of analog signal processing, we move forward for the digital signal processing. So it refers to processing of signals by digital systems in both real-time and non-real-time applications. For the analog signal processing, what we have seen that system actually supports real-time applications. Okay, but here regular system can be used in both real-time and non-real-time application. That is the benefit. Okay, the processing of signals are basically spectrum analysis to determine the various frequency components of a signal and filtering the signal to extract the required frequency component of the signal. The digital system can be a specially designed programmable hardware for DSP, that is digital integrated circuit (ICs), or microprocessor and microcontroller, etc., or an algorithm or software running on a general purpose digital system like personal computers. So that digital signal processing system can be also an algorithm or software. It is not mandatory, it will be some hardware. Okay, but normally the either reprogrammable hardware or software or algorithm. Okay, so basically digital processing of an analog signal consists of 3 steps: conversion of the analog signal into digital form, processing of the digital signal so obtained, and finally conversion of the process output into analog signal. So you can consider, if we just partition it, so first one, then second, then third. So in first one, it processed from analog input to digital input by passing that analog input through some analog input filter, then sample and hold circuit, then analog to digital converter circuits. So here at that point it will be a digital signal. Now that digital signal is processed, analyzed, modified through the digital signal processing or digital signal processor circuitries, or maybe some algorithm or software. Then whatever the output, that is also digital signal. That digital signal is next processed and converted to again into analog signal. So digital to analog converter circuit is used, then it is passed through output filter, and then we get our desired analog output. So thus that way the digital signal processing works. Now there are several advantages of digital signal processing or DSP over analog signal processing or ASP. So the most important among them, they are first point, flexibility. So flexibility in design. So digital implementation allows flexibility to reconfigure the DSP operations by simply changing the program. So if you change the program, if you change the algorithm, then that system can be modified and that can be applied to other application. Okay. So it is reprogrammable and flexible. Next point, that accuracy. DSP provides any desirable accuracy by simply increasing the number of bits, that means word length, while tolerance limits have to be made in the analog counterpart. Okay, so it will provide that more accurate results. Next point, third point, easy storage. Data signals can be easily saved on storing media such as magnetic tape, disk, optical disk, and solid state devices, SSDs, without loss of information. They can also be easily transported and processed offline in remote laboratories. So to process it online or offline, the data can be stored. Okay, and the data can be stored in the storing media that are portable also. So without any loss of information. So they are portable, so they can also be easily transported and processed offline in other areas, in remote laboratories. Now next point, fourth point, that is the processing. DSP allows for the implementation of more sophisticated signal processors than its analog counterparts do. Next point, cost effectiveness. with the recent advances in very large scale integrated circuit, VLSI, very large scale integration circuit technology, the digital implementation of the signal processing system is much cheaper. Okay. Perfect, next one, perfect reproducibility. No variations due to component tolerance. In our earlier slide, what we have just seen, that due to component tolerances, that ASP, analog signal processing, have the limitations, but here no variations due to component tolerances in the case of DSP. Next point, no drift in performance with temperature and age. Okay, because here in most of the cases DSP actually build on some algorithm or some software, so they have no effect on temperature and aging. Okay, so performance is not altered, performance is not degrade here in the DSP case. Next, immunity to noise. DSP is immune to noise. Next, easy processing of very large frequency signals, VLF signals. DSP is applicable to easy processing of the very low frequency signals such as seismic signals. Sorry, that will be very low frequency signals. Seismic signals, whereas an analog processing system requires very large size inductors and capacitors. Okay. Next point, time sharing. Digital processing of a signal facilitates the sharing of a signal processor among a number of signals by time sharing. That is also interesting. This reduces the processing cost, size, weight, and maintenance per signal. So, digital signal is stable, reliable, flexible, predictable, and repeatable. So, that is the gist of the advantages of digital signal processing. So, digital signal processing is stable, reliable, flexible, predictable, and repeatable. Now, there are certain disadvantages of the DSP, digital signal processing, over analog signal processing. So, digital signal processing also have some disadvantages. So, first one, that is the finite word length. So, cost considerations limit the DSP implementation with less number of bits. That is the, you have to remember, less number of bits, which may create degradation in system performance. Second point, system complexity. Increased complexity in the digital signal processing of an analog signal because of the need for devices such as analog to digital converter, digital to analog converter, and the associated filters. We have just seen that in the digital signal processing involves that 3 steps: the conversion of analog to digital signal, then processing of the digital signal, and then digital signal to analog signal. So for that purpose, there have complexity increased a little bit. Next, speed limitations. Signals having extremely wide bandwidth require fast sampling rate, analog to digital converters, and fast digital signal processors. But the speed of operation of the ADC and digital signal processors has a practical limitation. Next point, more power consumption. A variety of analog processing algorithms can be implemented using passive circuits employing inductors, capacitors, and resistors that do not need any power, whereas a DSP chip containing over 4 lakh transistors dissipates more power, around 1 watt. So in several real world applications, the advantages of DSP overweigh the disadvantages, and DSP applications are increasing tremendously in view of the decreasing hardware cost of digital processors. Now, if you just try to understand that analog signal processing, digital signal processing, or mixed signal processing graphically. Just look at here in the screen that analog system, that analog signal processing actually involves analog system. So they are basically continuous time signals and systems are used, and their analytical techniques are used, and analog electronic circuits are used. Okay. Now if you consider that digital signal processing, so they are used digital systems, discrete time signals and systems are used there, and numerical techniques are used, and also digital electronic circuits are used. So that if you just go from analog signal processing or analog system to digital system, you have to move through some interface, that is analog to digital conversion. Okay. And if you just move back from digital signal, digital system to analog system, so you have to move back through the same interface system where digital to analog converter is used. Okay, so this process is reversible. Now there are certain applications of digital signal processing, because digital signal processing is very rapidly growing field that is used in the many areas of modern electronics. So some typical applications, they are speech processing, speech compression and link of compression for voice storage system, and for transmission and reception of voice signals, speech synthesis in message warning systems. If we consider communication system applications, their elimination of noise by filtering and echo cancellation, adaptive filtering in transmission channels. If we consider biomedical application, then medical diagnostic instrumentation such as computerized tomography, CT scan, X-ray scanning, magnetic resonance scanning, spectral analysis of ECG and EEG signals to detect various disorders in heart and brain, scanners, patient monitoring and X-ray storage or enhancement. If we consider consumer electronics application, so digital audio and digital TV, electronic music synthesizer, educational toys, FM stereo applications and sound recording applications. If we consider that seismology applications, spectrum analysis of seismic signals, that is the signals generated by movement of rocks, can be used to predict earthquakes, geophysical exploration for oil and gas, volcanic eruptions, nuclear explosions and earth movement. If we consider image processing application, image representation, image compression, image enhancement, image restoration, image reconstruction, image analysis and recognition, pattern recognition, robotic vision, satellite weather map and animation, fingerprint matching, medical imaging, identifying hidden images in the signals received by radars. Okay, if we consider navigation applications, global positioning system, satellite signal processing for air, sea and land navigation. So also if we consider in terms of Indian global positioning system, that is now you know that NAVIC system, that is also used the digital signal processing. Next, genomic signal processing, so processing of sequences of a human genome to explore the mysteries. Military application, if you consider, then radar signal processing, sonar signal processing, navigation, secure communications and missile guidance. If we consider instrumentation and control application, spectrum analysis, position and rate control, noise reduction, data compression, digital filter, phase lock loop, PLL, function generator, servo control, robot control and process control. Now, here are some examples actually I have given in this slide. Okay, all the three examples are from the image processing area, image processing applications. So first example, that is noise removal from image. So in the left hand side here, the first figure you can find that is noisy image. So by using that digital signal processing, or digital image processing, rather we can say, we can remove the noise and we can enhance the picture quality. Okay. Here also some two parrots are some picture of two parrots that is noisy, and after noise removal from the image, they are that picture are more visible, more clearly visible. Okay. Image enhancement. Here are the example of image enhancement. So you can find that image of a window, okay, that is not clearly visible. After enhancement, okay, you can find that gray images, okay, and the details of that windows, okay. Now another example, third example, that may be like that the use of digital signal processing for zooming, replacing expensive and bulky camera lens. Okay, so suppose one figure is captured through your mobile phone, and we can easily zoom any area of that picture using the software, using that digital signal processing software that's inbuilt into your mobile phone in terms of some apps. Okay, so you can just zoom that area. Suppose we want to zoom the eyes, okay, of a ape or baboon kind of thing. So you can easily zoom that eye here, okay, without, okay, using any expensive or bulky camera lens or external lenses. So that can reduce your cost to process that particular picture or image. Now that digital signal processing, that subject that can be that can be used in different research areas. Okay, you can say that they have this subject have the huge prospect in with different research areas. Some research areas I have actually mentioned here, that self-directed perception and control for vehicular system, adaptive and distributed power allocation by optimal techniques, programming models for high performance computing software, radio frequency and digital signal processing and applications, nanoscale signal processing and communication technology, direct RF front-end digitization and processing, single chip enabled digital signal processing, learning based knowledge aided signal processing, new signal processing applications such as smart 3D TV, ultra high definition TV and 4K TV, cognitive radar and multifunctional reconfigurable antenna for signal processing, cloud computing trends in signal processing, developments in diversity technology, industrial Internet of Things signal processing, that is industrial IoT, IIoT signal processing, advanced seismic data or signal processing and analysis, enhanced massive MIMO wireless system, joint resource and power spectrum allocation for cellular networks, signal processing in cellular wireless body area network, WBAN, real-time digital signal propagation and modulation, wavelet based multi-resolution signal analysis and processing, wireless multi-channel signal processing system, learning based signal authentication for cyber security system, spectrum analysis in homographic signal processing, digital beam alignment and beamforming or millimeter wave signals, real-time blind source separation and extraction application, pilot signal transmission based on waveform and modulation scheme, digital speech recognition and speech synthesis in signal processing, channel modeling and channel characteristics in signal processing in smartphone, smart IoT signal processing, real-time data compression in digital communication, optical character recognition OCR in defense system, digital speech processing in smart home aids, advanced consumer electronics in industrial applications, radar applications for surveillance systems, audio and video signal processing in gaming applications, medical signal processing in biomedical applications such as hearing aids, BP testing and EEG testing, digital image processing in computer vision application, smart clinical and wearable devices in healthcare application. So here are the some references I have taken, and you can also go through some reference books that is mentioned. So thank you for your attention. So this is the end of this presentation. If you have any questions and doubt, you can ask me, or you can also go through my email ID that is mentioned in the slide. You can also mail me regarding your doubts.